This meeting is being recorded.
What we see in this next problem is a different reaction type. So chapter 8, problem 22. This is our first example of a catalytic. Right, so catalytic is the first word, and hydrogenation, right? Hydrogenation. So we're going to be adding hydrogen across our alkene, across our pi bond now. So what we need to know are what types of metals are involved. So we have nickel, palladium, platinum. If we see any of those used as a reagent, they are catalyst in or common catalysts used in a catalytic hydrogenation. And then we also need to add to both sides H2, right? So that's going to be our other, the top of the arrow here, our reagent. So we're going to add hydrogen across this pi bond, and depending on whether or not we create any chiral centers, we're going to see if any enantiomers will be in our products, right? So with A here, I'll write A down here. If we add H2, so we add a hydrogen here, we add a hydrogen here, our product will look pretty similar, right? Minus the pi bond. So that's our product for A. For B, so we're going to do the same thing, right? So we're going to take our six-membered ring, and then I'm going to add hydrogen on this side, hydrogen on that side. So I end up with that as my product. So we're going to see a pattern here with C, right? So I'm going to draw everything as is, right? Minus that double bond. So I added hydrogen here and hydrogen here. So what was created over here is a chiral center. So we're actually going to place this on a wedge to be a more correct structure. So you have to be careful. If you create a chiral center, you have to designate it with a dash or a wedge. The other side was not a chiral center because there's two hydrogen atoms on the other side, where we have an ethyl and a methyl, and then what's this? 1, 2, 3, a propyl and a hydrogen all coming out of that carbon there. So our product for D, in this case, again, we're just going to remove that double bond, and we end up with something that looks like this. We've added hydrogen here, and we have more than one of the same group coming off of each carbon, so we do not have any chiral centers created with example E. So our last example here, oh, I forgot to mention earlier when we had that chiral center created here, we would also have the enantiomer. Right? So we can't forget that there's two products with that reaction. So when we look at E, the reason I mention that is because we will create a chiral center, or two actually here, because both of these carbons, when they gain hydrogen, right, on either side here, we're going to see 1, 2, 3, 4 different groups on each of the carbons. So what actually results due to the necessity of syn addition, right? If these are my methyl groups and my hydrogens are hidden, I actually get a meso compound and only one product. So one product. No enantiomer, even though there are chiral centers present.